When I originally sat down to think about what project I could do to develop a skill I'm not good at, or to showcase something that I am really good at, I had a hard time deciding what to pursue. Compared to my peers, I'm a lot older and have a lot of experience. And at the risk of sounding a bit full of myself, I'm actually quite good at a lot of things. That's when it struck me. What I'm really good at, I mean really good, is perfecting new skills in a short amount of time. Now that sounds like a unique value proposition. From this idea, a challenge began to form. How can I employ this skill in the field of education? I decided to ask myself, what activities and experiences can I take part in to better understand how to incorporate cross-curricular learning? Build a CNC. Feeling a bit lost? Don't worry, we'll make sense of this together. I decided that what reigned supreme would be injecting out-of-the-box curricular thinking into the CNC build project. Just taking on the task of building a CNC would involve a lot of different skill sets. Communication and feedback with various parties would be critical. In short, all the aspects that come along with cross-curricular education. But I wanted to take it a step further. I decided to let this idea of building a CNC flow over into my other college courses and thereby truly making it a cross-curricular learning activity. So let's sum up that intro a bit. I'm going to explore cross-curricular education. I'm going to do this by building a CNC. I'm going to challenge myself further by having the process involve and tie into other classes. And I'm going to do all this with leaving for 3 weeks in the middle of it to do a 90-kilometer ski race in Sweden. Oops, I forgot to mention that little hiccup. That's okay. We'll figure out how to tie it in somehow. So, the build came off to a pretty good start. And by that I mean my 3D prints were failing, my plasma cutting idea wasn't nearly precise enough, and I still needed to figure out how to make use of that time that I wouldn't be in the shop. Right off the hop, my hopes came crashing down when my proof of concept, troubleshooting a useless box I had built a few years ago, proved that my timeline just wasn't going to work. So what did I do? I talked to my instructors and rehashed my timeline. Ooh, Gantt chart. Fancy. I fine-tuned the 3D printers to improve the quality, and I hatched a plan to have the CNC machine shop in the college manufacture my metal gantry parts for me while I was gone in Sweden. It was all coming together. In the days leading up to my departure, I even got the CNC dry assembled with some plexiglass gantry parts I was able to cut on our laser. Oh yeah, and I also figured out how to make use of my time in Sweden. I connected with the middle school in my mother's hometown of Gnosjö, or as my 6th grade English teacher would say, Gnosjö. I arranged to spend a couple days observing the woodshop class there. It actually worked out really well, and I got some great cross-cultural experience that I was able to bring back and share with my classmates. Scan this QR code if you want to watch a video tour I made of my time there. I returned to Canada with my spirits high. I had succeeded in my ski race, 9 hours, 33 minutes, and 4 seconds. And now it was time to get down to business. And then the blocks came tumbling down. I went to connect with Jesse in the metal CNC manufacturing lab. They hadn't started on those parts yet. I have to go back to the drawing board with those plasma cut pieces. Remember those? The ones that didn't work? I sat down for my progress report with Matt and Jeff. That didn't go well either. While I felt I was on track, Matt's words were, and I'm quoting here, "I'm getting that spidey sense tingly feeling that you aren't going to complete all the goals you set out for yourself at the beginning." I mean, he had a point. My machine moved with plexi pieces, but those wouldn't withstand the force of actual cutting, and I didn't have a great plan for how to make them in metal. I also had to design and produce 3 projects, 2 of which would need assignment handout sheets created as well. All of this in just 3 weeks, and my machine wasn't near to being assembled. But to my advantage, as we established right in the beginning, I'm good at developing new skills in a really short time. Furthermore, if anyone, even Matt, tells me they don't think I can do it, you better believe I'm going to do it. I kicked it into high gear. Matt and I spent some time with the plasma and figured out how to improve the quality of my cuts. And by the end of the day, I had all my metal pieces cut. I also put in some overtime and painted them at home over the weekend. Within a couple days, the machine was assembled and I was testing the limits. I had a pretty good idea of the projects I was going to build on it, and those machined quite nice. Not perfect, but nice. This is where some of that cross-curricular application between courses came in. In a demonstration lesson for my facilities course, I was able to troubleshoot the CNC with the class. Also, this entire time, I had been using first-hand experience I was getting to design a course on how to build a CNC with students. That was for my course development class. Nearing the end of this experience, I want to reflect back on my original question. What experiences can I partake in to better understand cross-curricular learning? Well, I think that was answered really well. Combining a whole mess of different skills and disciplines? Check. Interdepartmental collaboration? Check. Well, sort of. Dealing with things that don't go according to plan? Definitely check. Tying it all together with other courses? Check and check. At the end of the day, I feel I proved to myself and Matt that I just might actually be good at developing new skills in a short amount of time.